formulas of the probability. So we have known that. Next, so we'll say that what is the concept of the Bayes theorem? Bayes theorem, it will provide the way to calculate the posterior probability of each hypothesis given the training data set. And it can be used as the basis for learning algorithm that will going to calculate the probability of each possible hypothesis and the most probability. And next we're going to see with the brute force based concept learning algorithm. So what is the meaning for the brute force based concept learning algorithm? We're going to assume the learners some infinite hypothesis H defined over the instances space X, which has to learn the target concept value while H belongs to 0, 1. So here Learner, learner is given some of the sequences from x1 to d1 with the sum of the instantaneous value with respect to the data set, where this xi is some of the instances from the x, where di is the target value for the xi we have taken. And again, this sequence of this target value, which can be written as d is equal to the data sets from d1 to dm. So this is what the brute force map hypothesis learning algorithm. So in the first step that H belongs to hypothesis and calculate the posterior probability. So while calculating the posterior probability, so the probability of H over D, which is equals to probability of D over H into the probability of H. And again the output hypothesis, that is a maximum hypothesis, that is argument maximum of probability of H over D. And next, let us choose the probability of H and as well as the probability of D. So there is choosing the posterior probability and the prior probability. So first we're going to initialize with the training data. So that D noise data is a free data and we need to calculate the target concept, and we should not have a prior reason to believe the any of the hypothesis. Next, what value should we specify for the probability of H? So that in place of this probability of H, in the previously that is the map, that is maximum a hypothesis. We have taken that value as a 1. But in case here, what value should be taken or what value should be specified for the probability of H? So here, given no prior knowledge that one hypothesis more likely than other, it is reasonable to assign the same prior probability to every hypothesis H in H. Assume that the target concept is contained in H and it requires that these prior probabilities, the sum will going to make up the 1 as the value. So that is probability of H is equals to 1 over H for the hypothesis. What should be taken for the probability of D or H? So here in this probability of D over H, the probability of observing the target value, that should be in a fixed value. So that we should not give the probability of D over H, which is equals to H the I. So in place of the D over H, either we can give the value as 1 or we can give the value as 0. Only if Di is equal to H of Xi, or if it is 0, the value should be in other ones. So here in place of P of D over H, we are given the value as 0. So totally this will become an 0. So now the posterior probability, the entire posterior probability of the hypothesis, it can be consistency with the 0 only. Next. So this is what in place of this D over H we have given as a 1 over H. If it is 0, the complete terms will become 0 and this is what only the value. So this 1 over H we can written as a version space of the hypothesis. So here in this version space of the hypothesis, so we have written that P of D is equals to version space with respect to H. So if that H and H get cancelled, so we'll get the final hypothesis value, that is 1 divided by version space of H over D. So at the final, we can give for the probability of D over H either 1 by version space or it can be a 0. So this is a value if it is consistency with the D and it is a 0 for the other parts. And so just here that given what is the relation we're going to make the COMAP with the concept learning methods. So here we have taken the final value. Either it can be a consistent with respect to 2t or it can be a 0 if it is otherwise. Next topic, that is a evaluation of probability statistics.